All right, so today we're going to be working on chapter 6.1. This is the law of sines. So remember that in this small unit right here, we're working on triangles. We just finished right triangle trigonometry. That's what it's called. And you guys are using the sine, cosine, and tangent, otherwise known as SOHCAHTOA. In this last unit right here, we're going to be working on triangles again, but it's not going to be right triangles. Not saying you can't still use these on the right triangles, but if you have other triangles that are not right triangles, then you can use these next two lessons. So this first one is called the law of sines. Right? So the law of sines involves a triangle that is not a right triangle, meaning a triangle that doesn't have a 90-degree angle in there. Right? And that triangle, we'll call it triangle ABC. So for that triangle, let's go ahead and label these. And I want you guys to pay particular attention to how we're labeling these triangles. Okay. So go ahead, and if you haven't yet, draw a triangle. That's not a right triangle, so no 90-degree angle in there. And you're going to label it triangle ABC. And you can label it any way you want. And you always want to start with labeling the vertices or the corners of the triangle. So I'll go with triangle A right here, capital A, and we want to use capitalize, capital A, capital B, and it doesn't matter the order you write, you name it, and capital C. Right now, so ABC or capital ABC are going to be the angles, right? So angle A, angle B, angle C, and across from angle A, so across from angle A, we're going to label that as side A, and we use lowercase. And so across from angle C is going to be side C, so lowercase or smaller. Across from angle B is going to be side B or lowercase b. All right, so can I keep that in mind when you're working on that? Okay, so triangle ABC with side A, side B, and side C. So if you haven't drawn your triangle, you're a little behind, go ahead and pause this video and draw your triangle ABC with the labels capital A, capital B, capital C for angles ABC and side A, side B, and side C in their respective place, which is across from the angles A, B, and C. Okay? So when you have the situation of a non-right triangle, and again, I mentioned this before, but you can also do this with a right triangle. Okay? If you have it with a red, if you have a right triangle already, okay, it is much easier to use SOHCAHTOA. Okay, so again, if you have a right triangle, you can still use this, but it's much easier to use your SOHCAHTOA. Okay, it's much easier to use that. Okay, and this is from the right triangle trigonometry that we just finished that small unit. Okay, but if you don't have a right triangle, then you should use law of sines, and in the next couple of days you'll be doing the law of cosines. Okay, so if you have triangle ABC, then this is what's going to happen. And you can have this setup, and this is three-part equation. Okay, and you don't have to use all three parts, and actually you should not use all three parts. Okay, so the law of sines states that your side A is going to be divided by the sine of A. That's why it's called the law of sines. Okay? And that's going to be equal to side B divided by the sine of B. Okay, so you will use just those two, right? Or you can say side A over sine of A, and that's going to be equal to side C over the sine of C. Or you can call that, you can say it's the side B over the sine of B is equal to side C over sine of C. Okay, vice versa, or in whichever order you want. Okay, and with that, oh, you can also flip it around. Okay, so you can also say that if you're looking for an angle, for example, you might want to start with sine of A first. divided by side A. And you might want to let that equal sine of B over side B, or just lowercase b. Okay? Or you can say sine of C over side C. So you can use any one of those situations. All right, so let's go ahead and let's do two practice problems. All right, but this is what we call the law of sine, and and I want to make sure that we understand that if we're using the A's over sine of A, B's over sine of B, and C over sine of C, this is if you're finding, you can write this down if you want, finding a side. Right? If you're looking for a side, a missing side, or the length of it, you would use this ratio, okay, or this law of sines ratio. If you're looking for an angle, then you would utilize this setup, right? And this would be if you're finding angles or an angle, right? So if you need time to pause the video, go ahead and pause it. I'm going to move on to the next, to the example. All right, so go ahead and take a moment. You can pause the video if you want. If you need to copy this down onto your notes. All right, so we want to find the remaining angles and the remaining sides. Okay, so while I'm just kind of just blabbering on and talking about it, you can take this time if you don't want to pause it to go ahead and jot this down and put it into your notes. Okay, but as I'm talking about this, right, you might notice that we are missing side, or excuse me, we're missing angle A, right? We don't know this angle right here, so we don't know that. So we will have to find that angle, and we're also missing side A right there. Okay, and what else are we missing? Well, we have angle C up here. We are missing side C. Okay. And we do have angle B, and across from angle B, we also have side B. So we do have the B's done, right? We have angle B and side B. You know what? I just realizing I need to pull up my calculator. So if you want to use a calculator to verify, okay, go ahead and utilize that. Let me see. I'm going to end it, okay? I'll be right back. All right, so I'm back. Right, that may have seemed like 2 seconds for you, but that took me like 3 minutes to find my calculator. Oh, my calculator is still hiding on the other side. Here, give me a second. Let me pull up my keyboard. So my calculator is right there. Let me actually just do a little fiddling around. Let's go into emulation option and let's stay on top. Right, so it's going to give me that weird little calculator screen or skin on the top. Okay. All right, so let me move this over to the side. Right, so as I mentioned earlier, we do have side A, or we are missing side A, angle A, and side C. We do have side B and angle B. So currently, let's say we want to find. So actually, one of my suggestions is you want to start with the the letters of the angles and side that you have everything about that you know about. For example, you know about angle B and you know side B. So those are going to be your kind of like your certainties. Those are always going to be true. So you want to use angle B and side B. So I'm going to start with, so let's find side C. So we would utilize side C along with angle C. And you're going to go ahead and play around with this idea right here. Right? So you see how I kind of marked the two the two letters that I'm utilizing. I'm using the B's and I'm using the C's. So I'm going to start with what I know, and I know side B, right? So side B is 27. So in your law of sine, so I'm using side B over the sine of B is equal to side C over the sine of angle C. Okay, so if I'm using that, okay, which means that side B is going to be 27 because it's opposite of angle B. So I will start with 27.4 divided by sine of angle B, which is 28.7 degrees. And these are in degrees. So when you go to your calculator, so I haven't done that yet, but in a bit, you're going to be using degree mode. And with that, we're going to set that equal to side C, which we don't know. So we're going to use side C over the sine of angle C. So that's going to be sine of 102.3 degrees. Okay. And basically, if you look at my current equation, right? If you look here, this is my current equation, my current setup. I'm only missing side C, so I need to solve for that C. And to solve for that C, all I'm going to do is get rid of that sine of 102.3, and notice that it's on the bottom. So if it's on the bottom, that means that I'm going to multiply both sides by sine of 102.3 degrees. And I'm going to do it over here also. Okay, I'm going to squeeze it right here, sine 102.3 degrees. Okay, so if I do that, then my sine of 102.3 degrees will cancel, and that will leave me with just the value of C. Okay, and C is equal to what? Well, C is equal to all of this over here. C is equal to 27.4 times sine of 102.3 degrees divided by, and this is on the bottom, divided by sine of 28.7. So that's all I'm going to have to do, and I'm going to do all that in your calculator. Okay, you cannot do this by hand because you don't know what the sine, or even I don't know what the sine of 102.3 and sine of 28.7. So in your calculator, so all of this is going to be in your calculator. So you need to pull out a calculator, go online and find one, or use your Chromebook calculator if you like. But you gotta make sure that you have a scientific calculator. You can't just have a regular calculator. So in your calculator, you might see a little D or R or G. Okay, and that stands for degrees, radian, or gradient. Right. So in mine, if I hit the mode button, you'll see that I'm currently in radian mode, right, and I want to change it to degree mode. So you want to make sure you highlight degree, or you just make sure that degree is set. Or if you're doing it on your phone, make sure that you hit the degree button until your degree is set up. Okay. Each phone is a little different, so you can, and you might have to turn your phone horizontal. Okay, landscape for you new kids. Right, so now I'm in degree mode. See, and if I move over to radian, you see how degree is highlighted. So that means I'm in degree mode. So I'm going to go ahead and exit out of there. So all I'm going to type in is everything I circled earlier. So 27.4. Oh, let's do it like this. Let's put the top together. So you can never be too careful. So parentheses 27.4 times the sine of 102.3, and I don't have to put degrees because it's already in degree mode. So when I say 102.3, it already knows it's degree mode. Right? And notice that the sine has a parentheses. It starts off, and then we close it with a 102.3. Okay, but we want the 27.4 to multiply by all of that, so we need to close that parentheses to um, to match the beginning of the open parentheses. And then now we want to divide it by the bottom 20 sine of 20, and we don't need a parentheses for that because there's only one thing going on at the bottom of that fraction. So we're just going to multiply, or excuse me, divide it by sine of 28.7 degrees. And you see how when you hit sine, it automatically brings up a parentheses. You got to make sure you close off that parentheses. And again, you don't need to include the degrees because it's right in degree mode. And when I hit enter, okay, when I hit enter, it's going to give me 55.7. So that is what my C is equal to. And it's not degrees because remember, C, what we're looking for is the side. So this will be 55.747. Okay, you need at least 1 to 2 decimal places. I would say go with more if you can. I'm going to go with 55.747. I'm going to use 3 decimal places. All right, so this is going to be 55.747. Okay, and that might be in inches or in feet or miles or whatever, but it is definitely not in degrees. Okay, so that now we know C is 55.747, right? So all of that work, yes, I know it's quite a bit, but you're gonna have to go and do it again now for the A's. So let's go clean up our board a little bit. Okay, so we do know that now C is 55.747. So I'm gonna clean up a little bit because my calculator, my big calculator is taking up quite a bit of space. So I'm just gonna use this little teeny tiny space to work the rest of my work. So I'm gonna leave that C there for a little bit. Okay, so now I know that C is 55.747. Okay, and I'm gonna leave the red circles because I know I'm gonna utilize that again. But I'm gonna erase C and I'm gonna write down C is 55.747. And if you notice on here that all your decimals only have one decimal place, right? For example, okay, some of you guys might have learned this in back in science, but there's only one decimal place there, one decimal place here, one decimal place. So um, you can go with just one significant digit. So if you don't want to put 55.747, you can use 55.7 if you like. Okay, but I'm going to go ahead and stick with more decimals because more is obviously better, right? So you can just do 55.7 and that would be fine because that's a number of significant digits or sig fig. You guys might remember that from science class. So 55.7 would be right, would be the, um, meeting the trend of all those other decimals. But I'm going to go ahead, like I said, and I'm going to go ahead and use 55.747 as my final answer because I may use that side again. And if I use that side again, I want to make sure that I have the most accurate answer. All right, so now what am I looking for? Well, I have side C already. So I either need angle A or I need side A. Okay, I'm going to start with angle A because angle A is pretty easy. Angle A just comes from the angles that are remaining from your angle 102.3 from angle C and angle 28.7 degrees from angle B. So I would just have to subtract from 180 and I would get angle A. So if I just take my calculator and start with 180 because you might remember that there are 180 degrees in a triangle, any triangle, you can subtract 102.3 and then also subtract 28.7. Okay, and that will give you 49. So angle A we now know or we know now is 49 degrees. So now we know all the angles and we're going to go ahead and find our last and final missing information, which is side A. And again, I'm going to utilize angle B, the 28.7 degrees, and side B, which is 27.4. Okay, I'm going to utilize those because I know those are indeed the correct answer. Now, I know I did a pretty good job. Okay, I don't know what you think about me, but I know I did a pretty good job with the 55.747. But on the off, in the off chance that I may have messed it up, I don't want to use angle C along with that 55.747, just in case I messed up, or just in case I was mistaken or made an error in my discovery of side C. Okay, so just in case this is wrong, I'm not going to use the side C. I'm just gonna say, hey, that's what side C is, but I'm not going to utilize that to help me find any information about A because again, I may be mistaken. Not very likely because I'm pretty good, but you never know. So I'm going to utilize what I know for sure, and what I know for sure is angle B and side B. All right, so now I'm going to go ahead and try to find my information about A. So I did just find my angle A, which is 49, and now I'm going to utilize um, the angle A with the side A. All right, so since we have that side C recorded, I'm going to go ahead and get rid of um, my recording of what side C is, and I'm going to go ahead and start my law of sines again one more time for side A. So I'm going to go ahead and since I know that I need to find side A, I'm just going to start with that. So I'm going to start with A over sine of A. And this time, I'm not going to write the law of sines for you. You should already have this in your notes. If you need me to slow down, sorry, too bad. You have the pause button. Hit the pause if you like. All right, so A, which is side A, over the sine, and this is the sine of A, which is 49 degrees. Okay, and this is going to be written exactly like how the notes were first introduced to you. And then this is going to be side B, or how long is B, right? B is going to be the 27.4. So 27.4 divided by the sine of 28.7 degrees. And notice that you, for this relationship or this equation, you already have 3 knowns and 1 unknown. So you can now just solve for the A. And to solve for A, you have to multiply both sides by sine 49 degrees and by sine 49 degrees. Okay, and by doing that, your sines will eliminate each other, will divide out, and you will be left with A is equal to, and what is it equal to? Everything on your right hand side. So what is it equal to? It's equal to 27.4 times sine of 49 divided by 28.7 degrees. Just exactly like how I read it, exactly like how you see it on your screen or how you wrote it. So you're going to type that into your calculator. I'm going to write it one more time. So A is equal to 27.4 times sine 49 degrees divided by sine 28.7 degrees. And you're going to type it just like that in your calculator. You may want to put a parentheses around the top just to make sure that that information stays together on top. But other than that, you don't need much more, right? So go ahead and take a moment. If you need to pause this again and catch up, you can. But I'm going to go ahead and start typing it on my calculator. So I'm going to start typing 27.4. And you don't even need to hit times. You could just hit sine, because when you hit sine of 49, it automatically knows that you want to multiply. How cool is that? Okay. Oh, and I forgot to put my parentheses, the red one. So I'm going to go ahead and close that in parentheses. And I'm going to go to my beginning, and I'm going to insert. Okay, you may not have that on your calculator, but I'm going to insert. So you might have to delete everything on yours and start over. But I'm going to insert open parentheses, and I have what I need, which is parentheses 27.4 times the sine of 49 degrees, and then I want to divide that by sine of 28.7 degrees. Okay, and again, the bottom, I don't need a parentheses. If you'd like to put one, you can. I'm going to hit enter on that, and it's going to be 43.061. Okay, again, I'm going to put all those digits in, but you don't have to. Again, the significant digits are just one decimal place, so you can just put 43.0 or 43.1 if you like. I, on the other hand, it's going to put 43.061. So that is what my A is equal to. So now I know A, and I'm going to go ahead and clean that up, is 43.061. Right? So, to answer the question, did we find the remaining angles? Yes. And did we find the remaining sides? Yes, we did, right? Mission completed. Right? So that's that example. If you need to review this again, go ahead and start over. Right? Start over from the beginning, or start over from where this lesson began. Okay. So I might have some stuff going on there. Right. So let's do the last example. This is going to be a word problem. So let me move this down just a little bit so I can read it. Okay. So this one says example. Okay, last example for today. This one's a word problem. A pole tilts towards the sun at 8 degrees angle from the vertical. Okay, we'll talk about what that looks like, or you can just start thinking about it. And casts a 22-foot shadow. The angle of elevation, meaning looking up, that's what elevation is, from the tip of the shadow to the top of the pole is 43 degrees. Question is, how tall is the pole? Okay, so I'm gonna put all this my calculator back on. Okay, so you need to make sure first of all you read through this, and you might have to read through it 2 or 3 times. So you need to read through it 2, 3 times. Go ahead, read through it again. Pause it so you can read through it. Hopefully you're done with the second time. Hopefully you're done with the third time. If you're not, pause it so you can get through with the second and third time. I'm gonna start drawing this. Okay, so basically we know that there's a pole, and a pole is like a flag pole or like a stick that's sticking out of the ground. So you can draw the ground. Hopefully it's flat, and then it's gonna tilt, right? The pole is gonna tilt towards the sun. Oh, so let's draw a sun. So we got a sun. Put a sun right here, like that. We need a little time to draw your sun. You go ahead and pause this and draw your sun in. Okay, so that's my sun shining there. And I have a pole that's going to tilt right, at 8-degree angle from the vertical, right? And it's going to tilt towards the sun. So I'm going to go ahead and draw my pole. I'll put that in blue. So here's my pole. So if I was to draw a vertical pole, excuse my not vertical, but that's a vertical pole, meaning it's straight up and down. Okay. Well, if it's tilting towards the sun at 8 degree, then that means that it's going to be the same pole, but it's going to be like slightly tilted towards the sun. So we're just going to use that as a vertical, meaning the my straight up and down line. And it's going to be tilting towards the sun. So it's going to be this pole right here. So let's see. So it's going to be 8 degrees. So it's going to be that pole. And it looks like that. Okay, so it's a pole that tilts at 8-degree angle. So from the vertical towards the sun is 8 degrees. So this little itty bitty angle right here, that's 8 degrees. Right, and the let's see, and then let's see, and then it casts a 22-foot shadow. Right, so I'm gonna draw a shadow. We'll use purple for the shadow. So it's gonna cast a 22-foot shadow, meaning the shadow obviously is gonna be away from the sun. So let's say that's about 22 foot, right? So that's 22 for shadow. Okay, so that's my shadow. And that's 22 foot, 22 feet. Right? And then let's see, the angle of elevation from the tip of the shadow right here to the top of the pole is 43 degrees. We'll use green for that. So from the tip of the shadow to the top of the pole, so is 43 degrees. Okay. I don't know what happens to the rest of my shadow or my, okay. So we know that that much is 43 degrees. Excuse the technical difficulties. That's what we know that much is 43 degrees. The question is, how tall is the pole? Okay. So there's your situation. You're gonna have to try to go through and figure this out. All right, so if you need to make it pause the video for a second and think about what you know and what you don't know or what you can find out. So go ahead and pause it for a second. Obviously, I won't pause it for a second, but okay. So if you didn't find this out yet, but this right here is a 90-degree angle. And if the pole is tilting 8 degrees more, then this right here, total is going to be 98 degrees. So if I just kind of get rid of this vertical right here, okay? So 90 degrees plus 8 degrees. So total for this angle at the bottom is going to be 98 degrees. So this angle here, 90 plus 8 more degrees. Right? And if I know both of those bottom angles, then I know that my top angle will be 180, subtract 98 degrees, subtract 40, oops, 43 degrees. So my top angle is going to be 39 degrees. Now, why do I need that? Maybe I don't. Okay, maybe I do, but that top angle is going to be 39 degrees, and we're going to just utilize that. Okay. Now, do I need that? Yes, I do. Okay. We need that because we have an angle along with its opposite side, and we have those two. So we have the angle of its opposite side right there. So those are what we need to utilize our law of sines. Okay. Now, do we need to utilize the 98 degrees and the opposite side also? Do we need to find out, that length, the green side? No, we don't. Okay, because the final question says, how tall is the pole? So we actually need to find out, the length of the pole. So we need this right here. Okay, which means that we need to utilize, we'll use red. We need to utilize the 43-degree angle and the x, because those are opposites of each other. So those are both either a and sine of a, or b and sine of b, or c and sine of c. So we utilize that along with the 39 degrees and the 22 feet. So we're going to utilize that in our law of sines. Okay, obviously we don't have any labels, so you can go ahead and label whatever you want. Yeah, so I'm gonna go ahead and label this as, let's go with, let's call this A up on top, okay, and then B on the bottom. Okay, well, at least I'm gonna do that. You can do whatever you need to do, and C here. Okay, I'm not gonna label A, B, side A, side B, or side C, because we know side C is actually across from angle C. So actually, let's do that. I lied. I am gonna label that. So I will label that as side C, because that is across from angle C. Okay, but I'm not going to relabel that 22 feet, because that's going to be side A, because that's across from angle A. So those are the little details that you have to make sure you pay attention to. So I'm going to start with side C, because that's what I need to find, because that's the length of the pole, or how tall is the pole. So I'm going to start with side C over sine, okay, not side, but sine of angle C, which is 43 degrees. And that's going to be equal to side A, in this case, is 22 over the sine of 39 degrees. And from there, you're just going to go ahead and just solve for the C. You're going to solve that by multiplying both sides by sine of 43 degrees. And sine of 43 degrees. Okay, and why do we do that? Because we want the sine of 43 degrees on the bottom to cancel with the sine of 43 degrees on the top. And that's going to leave you with just C is equal to 22 sine 43 degrees over sine 39 degrees. And you're going to type all that into your calculator. So you're going to start with 22. Oh, let's do it right. Let's start with parentheses. Okay? And actually, you don't really need it because it's all multiplication, but it doesn't hurt. So I want you guys to kind of get used to that habit of doing that. So 22 times sine of 43. Okay, and notice that when I hit sine of 43, it automatically puts parentheses. So I need to close that parentheses, and I need to close the beginning parentheses also. So 22 sine of 43 degrees divided by sine of, and then as soon as I hit sine, you see how it already has a parentheses. So you're gonna put in 39, and you're gonna close that parentheses. Okay, and that's gonna give you 23.8. And in this case, we don't have to find everything. We just need to find out how long the pole is. So the pole is 23.841, or 42 if you decide to round it up. I'll leave it just the same. And that's going to be in feet, because I know the shadow is 22 feet, right? Okay, so if all we need to do is find out the length of the pole, you need to just have side C, okay? And you might want to just do a little error analysis, right? Just kind of compare it to your shadow, right? So is the shadow, and is that 23.841, is that comparable to that 22? Like, does it kind of make sense? Or, is that like, 284, right? Is the pole 284 feet, and then the shadow is only 22 feet, right? So you're going to have to kind of compare and see if what you're doing makes sense. All right, so that's it. All right, so if you have any questions, okay, shoot me an email or maybe check in the comment below, or you can always wait till I get back, or you can rewatch the video, whatever you want. All right.